Here we're going to take a given supply and a given demand and find the equilibrium quantity and the equilibrium price. Now, it is traditional to put price as a little p on the y-axis, and throughout this class we'll use x as the quantity on the x-axis. And I think just because of the two parts of the question that you see here, quantity and price, I'll go ahead and just actually label this way, quantity, and that might be the number of books or the number of mugs or whatever thing, and then right here, P here for price, right? Usually in dollars. So this is an equation that truly came from probably doing a point slope form, like there was probably a P minus 10 originally, but then adding 10 to both sides made it look like this. But you'll see the slope right here, and that is a positive slope, so we'll just draw that. Supply should always end up being a line with positive slope. And then in contrast, this negative slope right there, that's what should happen for demand. So we'll draw that in like that, demand. And the point that we're looking for here is the equilibrium, right? So this point right there, it's the equilibrium. And if I label like any point, any point always has an x value and a y value. Now, technically in our problem, instead of a y there, that's a p, but there's an x and a y. And so how do we find that point? Well, the math that we do is to take y equal to y, or we set these two things equal to each other. So we'll have 0.11 over 23 times quantity x minus 6 plus 10 equals negative 0.11 over 23 quantity x minus 8 plus 11. Now we do this whether the question is about equilibrium quantity or about equilibrium price, because equilibrium just refers to the point itself, and equilibrium quantity, equilibrium price, they'll both come up. But we need to solve this equation. You see that by setting p equal to p, there's no p's written here. This is an equation that only has one variable x. Now, while the equation looks really scary, just maybe a line above, let's point out, actually, let's not do the line above, let's do the following. What would we do if we had this equation instead? Right? What I'm writing down looks like a much nicer equation. It's of the same format, really. I mean, I know this number is weird here. It's a fraction that has a decimal in the numerator. Same deal over here. I intentionally, since the fraction value here and here, they're actually just opposites with that minus sign. That's why I wrote a 2 and a negative 2. And in this question, I'd make my first step to distribute 2 on the left and negative 2 on the right, and I'd have a thingy that looks like this. This is what my equation would look like, right? And so I'll do the same thing over here, right? If I distribute there, I'll have 0.11 over 23 times x minus 0.11 over 23 times 6. Now, why not a negative 6? I already took care of the minus sign here. In fact, it matches kind of the shape of that sign right there. Now, you could do 0.11 times 6 all over 23 in a calculator, but I think just leaving it like that, as messy as it is, will work out just fine. Same deal, we'll distribute just like we would have distributed negative 2 up here. This will be a negative 0.11 over 23 times x, and then a negative times a negative will be a positive. That matches, by the way, the same deal for having this plus here. So having taken care of signs, I'll just take the number, the fraction, ignoring the minus sign, and then this number 8, ignoring the minus sign, and then write the product of them right here. So 0.11 over 23, oops, 0.11 over 23 times 8, and then there's still this plus 11 that's hanging out, so we need to copy that. Now, this still looks kind of messy and scary, but I think of what would I do back in this equation. Maybe I'll box it, like right over here. Again, the equation I just boxed is not actually in our problem, but I think it's a useful way to see whenever you feel stuck and intimidated by how this looks, go back to what would you do here. And I see 3 terms on the left, 3 terms on the right. I'd probably add 2x to both sides. It's too easy to say that this and this cancel each other out, but that's not what would happen here, right? You'd, in this space, maybe I'll switch colors, add 2x to each side. Over here it'd be a 2x plus 2x would be 4x. Now it's a lot easier to collect like terms in this equation for sure, but over here, let me copy this first term, just down here, 0.11 over 23x, and then I'm going to add 0.11 over 23x to both sides, right? You have to add to undo that minus, so we'll have a plus 0.11 over 23x. And how about that's it on the left side? On the right side, there are two terms that were originally there. I tend to copy those first. It's just my habit. It's not the only way to do it. So I've copied those, and then where there's this term that was on the left, there's with this minus, so to undo it, to not have it on the left, we have to add 0.11 over 23 times 6 to both sides. So here's this adding on the right side. On the left side, we ended up adding by not actually just writing about it. And then there's this plus 10. To undo the plus 10, we have to subtract 10 on both sides. So minus 10 introduced on the left gets rid of having to write this plus 10 on the left. And then there's a minus 10 here as well. So while the right side looks super messy, it is just a number. If you wish, you could simplify 11 minus 10 as a 1. I mean, there's lots of other simplifications you could technically do, but I'm just kind of leaving it as it is. Right here, this is the thing that feels so messy when we only think about collecting like terms. But remember what collecting like terms actually is. It's taking the variable and factoring it out. So factoring out means writing the thing that's common only once outside of new parentheses. And inside the parentheses, we'll have this fraction plus that fraction. Right? So 0.11 over 23 plus 0.11 over 23. Now, I'm just trying to take an approach of doing this that's just convenient by not simplifying. This happens to be nice enough with a common denominator that you could have said all of what's in parentheses is instead 0.22 over 23. But you don't have to do that. You can do it that way. I'm just trying to give an approach that would work even if the fractions just in the starting problem had different denominators or whatever. Okay, and this is all over. The right side is the same, so I'm just going to do a bit of a copy paste here. And then finally, to get x by itself, we have this number times x. So we should just divide what is on the right side, as you know, and the left side, both by, let me try that again here. So we'll take this divided by what we're dividing by is this, so this 0.11 over 23 plus 0.11 over 23. If I now just get rid of all this work, it was nice to see everything step by step, but let me bring this all the way back now to do this and see up here in the question. We were asked equilibrium price, equilibrium quantity, excuse me, other order. But let's see what do we have here. This is an x value. So what we actually got, this number, whether you put it in a calculator or not, it is a number. And that's the x coordinate right here. Not the y, but the x. And so then x, well, that's the quantity. So this number right here, this whole thing that I'm circling right now, that is the equilibrium quantity. Now, how do we get the equilibrium price? Well, the equilibrium price, that's the p value or the y value. And you can use either equation. It does not matter which one you pick. Pick either equation. I guess, I don't know, it just feels a little more convenient to use this one just because there's only one minus sign here and there's two minus signs. But it doesn't matter which one you pick. All I'll do is copy this down, right? So little p is equal to 0.11 over 23. I've copied this much. I'll copy that left parenthesis. Now I need the value of x, which is, I get that it's a mess, but even in the homework, if you need an exact value, just copy paste, right? If you have this whole thing that I've highlighted in an answer box, that just can get copy pasted right there. And so that covers up to this much. We still need a minus and a 6. So a minus and a 6. We still need a right parenthesis from up here. So let's do that down there. And then up here, there's still a plus and a 10. Plus and a 10. And so this whole thing, I'll circle it right now. Right? That is the value of p. It's one way to write the value of p. If you plugged into the other, if you plug this x into the x right there into this other equation for p, while it will look different, the value is actually literally the same. That's, you know, what we get by setting these two equations equal to each other. So this is a p value, and p, or the y-axis, that's price. So that's why this one is the equilibrium price.